Hello. All right. Word up. How's it going? What's up, G? Yeah. Welcome. Oh man, it's week two, day 3. It's like you're almost done boot camp. What? Yeah. You know what's hilarious though? If this was the 10-week program, like, or not, I don't know. I was just gonna say it's like you haven't even started boot camp compared to like 10. I don't know. It's been a long night. So, 2 things. First of all, first point of lecture, the first kind of big point of news is I'm working on an intro to hip hop playlist for my my girlfriend's dad. So if you know any like dad-friendly hip hop, send it over to me. I mean, what I'm trying to do. Yeah, I'm starting off. Yeah, lots of old school. I'm doing what I think I'm gonna do. I'd like to make like a course of like intro to hip hop, music that gets less and less accessible as you go through it. So you start off with, you know, I don't know. You start off with "Just a Friend" by Biz Markie, like something easy to listen to, and then by the end of it, you're rocking out to like Death Grips and stuff. And as like a 3 playlist thing. It's so not yet. I started making this on the bus. That's a good point though. I'll throw some. Yeah. So we'll put some New York State of Mind. There you go. Add to queue. No, not add to queue. Add to my playlist. So if you do know any stuff, please send it to me. The other.
Is he committing to like listening to the whole playlist within reason?
I think so. So I'm gonna keep it to a max of 20 songs for the first one, right? And then do an edition number 2, or another 20. Yeah, like a volume 2. More like. Yeah, it's more like hip hop 101 and then 102.
Yeah, I was gonna say 102
Yeah.
is the follow-up.
So yeah, there's that, and then the other big point that I want to make a really important deal of is that I have a playlist called Nima's Good Vibes that I like to shill to every student's coming in. So Nima's Good Vibes, 164 songs. It's I've got some followers, you know, yeah. They're mostly students, so so it is public, you know. If you wanna, it's the weirdest mix of stuff. You can go from Norah Jones to Stormzy to some Billie Holiday, and then down to Fu-Schnickens. Yeah, I call this my whiplash playlist because you're like, oh man, what's going on? And it just keeps veering to the left and right. So I wanted to. Well, what's that? Yeah, whiplash. Like you feel good, and then you're like, I feel good, but different. That's the. Yeah. Yeah. Maybe whiplash isn't the best way to put it. But yeah, those were the important things that I wanted to get out of the way at the start of this lecture. Now, what we're dealing with today is particularly like networking and stuff. We're gonna ease our way into motivating the whole idea behind the lecture in like a minute, and then we'll start writing some code. So I think what we're gonna do for the first little bit is really just have a bit of a discussion. First of all, completely unrelated to the lecture, how did you enjoy yesterday's work? Not great? Oh no, why? Yeah? All right, we'll write this down. So your name is? Brian. All right. Brian, not great, but so valuable. There we go. Extreme. Your review's getting more and more glowing by the second. Yeah, extremely useful. Yeah, no, but I genuinely do want you to give feedback on, like, are there concepts that you'd like to go over a little bit before we dive into stuff? Yeah.
I thought at the end
Mm-hmm.
it wasn't like looking back on it, it's not as novel as I thought it would be because it's just testing, which we've done.
Mm-hmm.
But now we're dealing with async, and it shouldn't be that different. But I just felt like talking to other people as well. By the end of the day, like getting those last couple exercises,
Mm-hmm.
like it just wasn't computing.
Okay.
And yeah, that's what I heard from a couple other people. People are saying.
Mm-hmm. The last couple exercises just weren't making. So you felt like you had to like just mash stuff together to get it to work, or?
Well, I almost wonder, and I know you guys are putting out the 12 week, but if maybe breaking up or recalibrating that day or the end of the day in particular, like I felt like after we got through that last exercise, we were using recursion.
Mm-hmm.
Like I the last little bit was a struggle.
Mm-hmm.
But I felt like it was also very valuable, and I just felt like I had to go back and look at it again. Maybe that's the intention,
Yeah.
but yeah, it just yeah, it seemed like other people too felt that way about the end.
Mm-hmm. Oh. Ah. Mhm. Mhm. So we're talking about the. Mhm. Mhm. Okay, for the testing async values. Right. Yeah. Make it of that.
Yeah, I feel like I was copying pasting by the end of the day, not really grasping
Okay. All right. That's actually really valuable to hear. Thanks. Yeah.
I think one thing that that was kind of implied but not mentioned, and I think it would have been better if it was explicitly mentioned, was that synchronous code runs before the asynchronous code.
Mhm.
Like in relation to the event loop and stuff like that.
Mhm.
And so because of that, when we were dealing with like file systems like the read one
Mhm.
or the question one, we didn't quite understand at first that you can't return out of that. Like there was nothing. The scope no longer exists, but there was nothing that stated that, and so it was more just experimentation that we realized that the return happens before the return from that stack happens like before the actual event loop processes the web API for the queue, and so it's kind of like we didn't know that at first, and it made it complicated when we were trying to use recursion, and using recursion to go out of a function that doesn't exist anymore.
Yeah, that's already confusing. Yeah. Okay. Uh, huh? Yeah. The recursion one is specifically which one? Fun. Sweet. Fun. Cool. Sweet, sweet. Okay, that's really good to hear. Cause you're right. We are choosing it. And I don't think we're gonna get a little bit of a chance to work with async stuff with this lecture. So hopefully some of that stuff becomes a little bit clearer, but it's not in the same context as what we did yesterday. What we could do is like I'll inform tomorrow's lecture to maybe have some stuff prepared to go over that stuff a little bit more. But sweet, thanks for the feedback, Reno. Enjoying boot camp so far, though. Good stuff. All right, so today what we're dealing with is week 2, day 3. Networking. So we're gonna put on our best clothes. Yeah. Eat some hors d'oeuvres. Oh, where do you work? Oh, I also play golf. Yeah. And do our best networking. No, that stuff is not fun. You're networking with TCP and HTTP. Yeah, this stuff is fun. You ever So what we'll do is we're gonna start a little bit by doing a bit of review. I know you did readings yesterday, for example, on intro to networking and TCP. So what we will do is take a bit of a look at it'll look at what you know, right? And we'll build on top of that, and I'll throw some new stuff at you. And you go, "Whoa." So what does networking mean? Is anybody feeling prepared to begin that? Yeah.
Networking is communicating between computers.
Communicating between computers. And that's really all it is, right? Communicating between computers. We communicate between computers in all sorts of ways, pretty much in the same kind of way that we communicate between people, or organizations might communicate between each other, companies, or countries, or interstellar communication, right? At any kind of level, there's some form of communication happening between two or more agents. With computers, we're kind of limited to the fact that they're not sentient. So you can't just leave the computers to be able to decide how they'll communicate with each other. We need to come up with particular protocols for communication. We need to decide ourselves. Oh, I was wondering what was bumping against my leg, and it's the microphone. So we need to decide how the computers are going to communicate with each other, and then write that and set that in stone and move forward from there. So at a very basic kind of level, there's a medium that computers can communicate through. Right? What might that medium be? Two machines communicating through something. Right. Mm-hmm. Yeah, any medium, e.g. a wire, right? So a wire is something that two machines might be able to communicate through. People might be able to communicate through the medium of sound, right? Like through air, we could, well, the sound waves, right? We can, communicate through the medium of like vision, in the sense of like, sup, right? Like I can, like that's, yeah. There's all kinds of communication that like humans can, all kinds of mediums that humans can use. It is nonverbal. It's a lot of like, I painted a whole picture. That was, this is the Mona, master. Mwah. So, unfortunately, with computers, we're very much limited to at least wires, or I mean, we're not going to be working with like Bluetooth or whatever in this boot camp, but we'll say at the basic level, we're going to have two computers and they're wired to each other and they're screaming. Like they can both just scream through the wire. Right? The initial place that we're going to start with as far as like Stone Age communication for machines is it's the tin can with the string. Right? And anytime you want, you can just shout into it. Bah! And the other person, they hear it. And if they want, they can scream back. Now, let's not think about computers for a second. Let's just think about like real life. If in real life somebody had access to just scream at you at any time of the day, you're just walking and then bah! And you're like, stop, right? I can't get the things I want done. That's tough. There's also the fact that there might be many people screaming at you through the same wire, and they all have the same voice. Right? So there's all these different voices in your head yelling at you, telling you to do different things. It's madness. Right? It does sound like madness. Yeah, it's just just screaming. It's yeah, and what we have to do is eventually you scream back at the voices and you say, hey, you know what? How about, very nicely, you're like, how about we come up with a system, right? We come up with a system. Yeah. Like, we come up with a system. When you want to shout at me, you have to at least tell me who you are, right? At the very least, right? So the voices from being like, give me the money, like, go get whatever, they turn into like, hi, my name is Bob. Give me the money. Like, that's what. So you have some context as to like the voices that you're hearing, right? Another thing that we might say is, maybe one of the voices in your, this is now a thing about voices in your head, apparently, but one of the voices that's just like shouting at you really likes the sound of its own voice. So it'll start talking and it'll talk for like 45 minutes. It'll just keep talking. At one point, you have to be like, listen, I know that there's tons of other voices in my head that want some time. How about we decide that everybody just gets like a small time limit? Like you take 5 seconds, and then you just move to the side and let somebody else go for 5 seconds. And then that person moves to the side and then let somebody else go. Right? And what we've done is we've taken this idea of like a cacophony of voices, disorganized, just shouting at you, telling you things, right? To at least establishing some structure of how that communication can happen. Right? We'll say that there's like the wire itself, right? The wire itself is like one layer of how the communication can be transferred, right? That's one layer of it. And then on top of that, I might say something like, listen, how about everyone gets like 5 seconds, right? And then you move over and let the next person go. Right? That's another little bit of structure onto how the communication can happen, right? Notice this second part here, it's not a real thing. It's an agreement. Like there's a physical thing, the wire itself, through which the communication is happening, but then there's an agreement that we have, right? An agreement that we have over how people are allowed to use the wire. And then on top of this, I might put extra information, like another extra layer. You got the wire, the rule that everyone gets like 5 seconds, and then on top of this, I might say something like, you have to introduce yourself. Right? And here's another kind of layer of rules on top, which is a bit more specific, and it structures the communication a little bit more. Okay? When we're talking about networking, a lot of the time what you'll see is the word stack or layers. In fact, there's one called, I'm going to get this wrong, is it the OSI stack? Yo, I got it right. Nice. All right. The OSI model, which goes physical layer, data link layer, network layer, transport, session, presentation, application. All right. Repeat after me. No. There's in one particular mental framework for how networking can be thought of, right? Particularly the OSI model. We'll think about the physical layer, which is the wires themselves. The data link layer, which is how, like, I'm going to totally butcher this, but how like a machine can talk to the wire. And then the network layer, which is getting to the idea of how communication can go through the wires. Transport layer is getting to that idea of something along the lines of everyone gets like 5 seconds or so. Right? Like we're adding a little bit more on top. And the further away we get from the wire, the nicer things feel to us as human beings, right? The more comfortable we are. For example, if we're say you and I have just started, like we're like in a brand new relationship or something. That's not a horrible example. I'm thinking like let's meet my friends kind of thing, right? Like we've become friends, and I'm trying to introduce you to my friends, and we're just outside of the door of this dinner party. And I'm like, okay, here's something I have to tell you. When you go in, you have to remember, you make your eyeballs, they have to turn, and you have to center your pupils with other people's pupils, and then you have to vibrate your thorax, or whatever this is. The larynx, yeah, there's an X in there, right? You have to vibrate it, and then the sound waves will vibrate, and then I want you to really pay attention. The human beings, they will nod as their eardrums vibrate, right? And like I'm going into a little bit too much detail about how you should be talking to my friends. Whereas if I just told you, like, listen, Dave's super weird. Don't ask him about climbing, right? Like, just don't do that. You're gonna be stuck for like an hour listening to his trip to like about his trip to Nevada or whatever. Like, just don't ask him, right? Or hey, Sarah loves. Oh, wrong Sarah. Sorry. Let's go. Bradlina. There's no Bradlina in this office. Bradlina really likes baking, so you can talk with Bradlina about baking. And now you have a little bit of a different kind of understanding about how to interact with this person. Right? That's what we're talking about with the stack. If we're talking about networking with machines or like in computers, eventually you're able to say to somebody, hey, just open up WhatsApp, right? Open up WhatsApp and write hello and press enter, right? And that is dealing with like an application. The application underneath is dealing with all kinds of stuff, network protocols and all that, eventually down to the wire. The human gets to interact with the application to do the communication. Yes?
With software, would we ever have to really be like, hey, so you have to look people in the eye and vibrate your larynx? Or is that like hardware level and physical layer? And we're more at the stage where it's like you mentioned, where I can see some different protocols. Where it's like, yeah, don't ask Brad about politics. He's going to talk to you about and, like that kind of stuff, where it's just like more high level and as it relates to that particular instance, as opposed to more generalizable protocols that seem to be built into the system.
Yeah, as a web developer, you're mostly going to find yourself at that high level, right? As a web developer, you get to mostly deal with pre-designed protocols, but it's still important for us to understand that these protocols are built up, right? You're mostly going to be dealing in, like, yeah, like even you're going to be using transport and above, but you'll be doing things in session and above. Right? If that makes sense. So we'll be taking a look at what happens in transport today, for example. Now, that's not the right one. Now, there's a particular explanation of the protocols that we're using today that I found online that I really like. I just like citing my sources. So TCP, which is, oh man, transmission, what's the C for? Control protocol, is a transport layer protocol. Transport, transport. There's TCP, and TCP is often coupled up with IP, which is Internet Protocol. The way that I like to hear it described, the way that I like to describe it is that IP, the Internet Protocol, is kind of like it's kind of like a highway. It's like a highway between computers or machines. That anybody can like get on and just zoom down and go find other machines. It's just a highway. Have you ever tried walking onto a highway? It's like, oh, yeah, let's just stroll. It's not easy. You need a particular encasement, usually powered somehow, and that's what TCP is going to be for. Right? TCP is going to be the trucks on the highway. Right? So a truck on a highway, like going to find a particular computer. So TCP is the trucks on the highway. Now, the reason that we have trucks on a highway is because they're usually transporting something from one place to another. Right? The things that they're transporting, right, the load that they're transporting, we're going to say is HTTP. Right? So HTTP is the load on the trucks. And that's what we're going to be working with today, is the trucks themselves and then the load on the trucks. Now, I think what we're going to do to start off with is we're going to actually build a little TCP server. A little TCP server, and then we're going to make a little TCP client. I'm going to be using the word client and server a lot today, and you're going to be hearing client and server a lot going forward. A client and a server are two different programs. Right? A server is a kind of program that listens, does something, and then gives something. Right? That's a server, and like generally speaking. Right? Not even necessarily with TCP, but you're just going to find the word server everywhere. You're going to find the word server when you're talking about HTTP later this week. You're going to find the word server when you're talking about databases. You're going to find the word server when you're talking about video games, like all kinds of stuff. Generally, a server is where a bunch of data is managed, right? And it's someone or something that other people can talk to interact with whatever's behind. The people who are doing the talking or the asking, right, the less important bits are the clients. Right? So I might have a server, and there might be many clients all connecting to this server to retrieve some information. Right? What we're going to build is a TCP server first, meaning it's a program that's using TCP to listen for incoming data. It's a program that's got its ear up to the wire. It's got its ear up to the wire, and it's listening for data coming through. And the data that's coming through is formatted in a TCP way. And heads up, we're going to do a little bit of like a loopy kind of model. I'm going to set up the code, and then we're going to talk about it, and then we'll talk a little bit more about TCP, right? Because I know I haven't hit all the points yet.
Are you going to define client a little bit more after?
Sure, yeah, I could define, yeah, because we're going to start by just building the server, right? And then we'll build a client, and we'll go deep into exactly what a client is. Cool. So loosely speaking, though, right now, a client is anything that uses something else, right? In general terms. So for example, your browser uses the internet, so it's an internet client. And it uses something. So you may notice I have a server.js and a client.js. They're gone. We're gonna make a new one. All right, we're gonna make a thing and call it. Actually, it would be better if it was called server client. So let me just rename this to underscore server and underscore client. So we'll start by making a new file. This one's going to be called server.js. It's just one JavaScript file. The way I like to start my JavaScript files is to go console.log, hey-oh, and then running them. So if I'm going to bring up my terminal go. And zoop, and zoop. Okay. So I like to start off by putting in the very, very minimum code needed. And then we're going to write a little bit of code at a time and see how well we understand it. So I have this in CD week 2, day 3, networking TCP notes. And node, server.js, at the moment, all it does is it says hey-oh. And every time I run this thing, it just goes hey-oh. There is a module built into Node already for dealing with network stuff. Specifically, it's called net. I know const net equals require net. Have you seen the syntax before? Yeah, right? We're bringing something in from a module that already exists. I'm still going to run the code just to make sure that I haven't messed up the import. I'm actually bringing in something that exists. Because if I went like some garbage, require NEMA, like something that doesn't exist, my code will break. Right? Could not find module NEMA. Right? So net is good. And then the next thing that I like to do is console log whatever the thing I've imported is. And here it is. This is net. The internet, we're in. Right? What is this thing? What kind of thing is it? It's an object. It's a JavaScript object. Right? So we can deal with it as any other JavaScript object. Meaning, as we talked about yesterday, I should be able to go dot and access stuff inside of it. For example, if I look inside of the object, there's a create server function. Right? Neat. Right? A create server function. I could see net.createServer and just console that thing on its own. What I'll find is when I run this, what I get is I get to look at that function. Right? I haven't run it yet. Right? I just get to look at it. So here's what I'm going to do. I'm going to go net.createServer. I'm crazy. I'm just going to run it. Let's just see what we get. Right? go net.create server. We'll go node server JS. All right. Whew. Whew. You want servers? We got servers apparently. Something's happening. Do create server, and then we'll pass it. So so we got net create server. Now there's a couple other things that I might need to do in here. For example, I've already got this pre-written. I'm going to do my best to not flip back and forth, but I just want to show you this one line. We can tell apparently a thing to listen. And I'm going to take whatever the return value of this net create server is, which we could technically look at if I wrapped it in a console log statement. I could see what comes out of it. It's a server, right? Apparently, it's a server object. I can save that in a variable. Const server equals net create server. Now, a server is just a little bit of a program. Right? My scripts in JavaScript, they'll run and then they'll end. JavaScript's very lazy. It won't like wait for you to have more stuff. It just does the bare minimum and then it goes off. And it technically, it's born and then it fizzles out. It just dies. So I need to tell JavaScript to stop. Okay? I need to tell it to stop and just stop there and wait. I can tell it to listen. Okay? So a server is a particular kind of object that I can tell JavaScript to have it just wait and listen for people trying to talk to it. And specifically what I'm going to do is I'm going to tell it to listen on a port. Right? Your computer is able to talk to many different machines at the same time. And the way it's able to do that is on your computer, there's lots of little ports that are reserved for communication to go through. Right? Generally, what we're going to do is when we start a server, for example, we'll tell it to listen on a port. A port is like a little window. And the port can be used by other programs on your machine to talk to it. Right? Or a port can be used by programs on other machines to talk to you. Yes?
Are there a finite number of ports?
There is a finite number of ports, but there's so many of them. Yeah, well, I mean, we could.
It's like max safe integer.
Yeah, like how many ports?
In the reading yesterday, compared it to an extension of a phone number. If the phone number was the IP address. Would you agree with that?
Yes, except let's put it this way: the wow to the except. It'll be like this. This is going to be like insane. I just need to draw it. Like, say this is your machine, right? And somebody can come in and they'll say, "Hey, I want to talk to port 80," right? Or they can say, "Hey, I want to talk to port 1337," or I can talk to 1017. Right? I can talk to all these different ports, of which there are like 65,000. You can pick whichever ones. And on the other side of it, like on your machine, so these are people wanting to talk to you. On your machine, like you might have many different programs. For example, maybe I have a node server. Maybe I have Minecraft or whatever, like all kinds of things running. And I can tell each one of these that they want to register to a particular port on my machine so that other people can talk to it. So maybe my node server right now is connected to 1337. Right? Like I tell it to connect in my machine to port 1337. So anybody who has access to being able to talk to my machine, so maybe it's somebody on my network, maybe it's another program on my machine, maybe it's somebody across the world who I've given somehow like my IP address and they can connect to me. They can say, connect to Nima's computer, Nima, and then they'll have to say, : which port. So they might say :1337 to be able to access this program, right? Yeah, so NEMA would be like, I would have like an IP address, or I'd have like a domain name or something. But, no, IP address, my bad. But if I don't have one, if I just say NEMA, then there's a default port, which is 80, right? Yeah, if you don't, like, it'll just, is 80 or 8,000, I always forget. But there is like a default port, but it's usually, is it 8,000 or 8,000? Yeah, 8,000. There's usually a default port. There's something running on there often. Right? Like you might already have something on your machine that's just running there already. So you can come up with literally any other random number, and whenever you need to connect a program to your server, you would tell it to go to that particular port. Does that kind of explain why it's not exactly like an extension, but it's more like an apartment with one, like, what do you call it? With like a penthouse that's like the most important one. It's like the reserved one. You had a question, then you had a question?
For the ports, is this like a way of setting up conditions on how they communicate with your machine? So like each individual port, you can put like limitations on what that, like whoever's communicating with you or communicating out.
Yeah, I can say that people are only able to communicate through 1017 using HTTP, right? But people can only talk through this port using something else. Or only this program is allowed to talk through this port. Like I can do that kind of stuff, and that's where you'd set like a firewall or whatever. You'd like block these things. Right? As far as we're concerned right now, though, I'm just going to take my program, my node server that I'm running, and I'm going to register it. Right? I'm gonna tell it to start listening on a particular port, and I can pick any one that I want. Right? So I'm gonna pick a number. We'll go with, anybody got a favorite number today? 9, okay. Let's pick a 4-digit number. 9999, all right. So we'll listen on port 9999. Hopefully I don't already have a program running there. If there is, one program per port, yeah. If there is, then I'll just get an error. It'll say something like, actually, we'll cause an error together. It'll say something like there's somebody already there. If I go node server JS 9000 now, or on 9999, what do you notice about my program? It's just listening, right? It's just waiting, right? We use the word hanging. It's just there, it's just waiting. I'm going to open up another window, and what I'm going to do in here is I'm going to, while this server is running, I'm going to try and run the server again. Right? So I'm trying to run a second server on the same place. Right? And I got an error. And this error here says address in use. Right? The port 9999, so this is to your question there, is already in use by the other server that I'm running. Right? So if I wanted to run two servers, I'd need to make sure that they're running on different ports. Right? So I'm happy with my one server right now running on 9999. And this server is technically just listening. It's listening. I could tell it to even, let's just say console.log listening on 9999, just so that I can remember for myself. But what I am going to find is, if I try to somehow talk to this server, right, the server will hear me, but won't necessarily say anything back. There's a couple different ways that I can talk to a server, right, using like TCP. The way that I'm initially going to do it is using my browser. I'm going to make a request to localhost :9999. Localhost means my machine. When I make this request, what do I notice about this thing? Yeah, this thing is spinning because it made a request, but it didn't get anything back, right? If I tried to make a request to localhost some other number, like 6472, then when I enter, this thing immediately ends, right? It's either the one that went to 6472 ended, or the one that went to 9999 is hanging, right? Meaning that this actually connected somewhere, right? See, this one here says this site cannot be reached. If I wait long enough, my browser might eventually decide not to do anything, or yeah, it might decide just to say, hey, the server didn't respond, like it took too long. But I know that a connection has been made. Right? Now, I want to maybe start by having my server say that somebody connected to me, right? I would like to say something like, when someone connects to me, right? Console.log, hello, new connection. Right? I'd like something like that to happen. We're going to have to think a little bit about how we would like to write this code. Right? If this is a thing that I'm trying to describe to someone, right? That when the server has started up, then when like it's listening, when somebody connects, I want to print something out. Can somebody come up with just like your dream code for how to write this? Yeah. Mm-hmm. Yeah. So if someone connects, and then we're just going to say in here right now, like just a console log, but later we will do a shooting of a message. What I want right now is every time we connect, my server should just in the console print somebody tried to connect. Right? It's not going to send anything back yet. Yeah.
In regards to console log, are we supposed to be transitioning to the right? No, it doesn't.
Yeah.
Doesn't really matter.
Yeah. The only reason that you would use the system, I always forget, the stdout.write. Yeah. The only reason you would do that is so that you can print things on one line, because console log automatically adds a new line at the end of it. That's the only thing. So we might use this. We're probably going to use console log for the most part. For the standard out, like you don't use it very often. In this case here, though, this structure I really like. If someone connects, right? This is pseudocode. If somebody connects, then console log. Right? Here's the problem, though. We learned about async stuff yesterday. Right? We learned about async. My script is just going to run from top to bottom, and then when it's done, it just ends. Right? In my case, I do have this nice asynchronous bit that says server listen, which starts off the thing that keeps listening. Right? But this if statement is only going to run once. I need this if statement to be like saved so that it'll run eventually. Yes. I might do something like a set interval, right? Do a set interval. So maybe set interval and say something to the tune of maybe every 100 milliseconds, right? So like pretty quickly, every 100 milliseconds, I want you to see if someone connected, right? And I might have a function, const see if someone connected. I might have a function that does something like this, right? So maybe I register an interval to see if somebody connected, then console log. This actually makes a ton of sense, right? We're going to have to constantly listen, right? Maybe there's something that is inside of the server that says whether someone has connected or not, right? Maybe there's like a Boolean inside the server that says whether someone's connected. Maybe inside the server there's something like however many connections there are, right? And we can see if the connections is more than one or something like that, or if it changed its size or things like that. Like we could write all kinds of code to see that. But what I really want you to focus on is this idea of like, maybe we'll have to set an interval. This is a thing that's going to have to happen regularly. Yes?
Just for clarity, so in that that theoretical thing, you're accessing a key property within the server object.
Yeah, within the server object.
Dynamically change.
Yeah, right? Maybe it's in there. Now, I want to stress the code that we've written here, this thing here, not the actual code that we're going to write. Right? What I'm trying to get you to do is think about the structure of how something like this should exist. Right? It's important to see that it can't just be an if statement on its own, because an if statement is just going to be synchronous and it'll run and then it'll be done. What we want to do is register something to happen. So doing a set interval works fine, but since this is such a common thing to do, what we will do is we'll say, hey, when the server gets a new connection, right? This is just going to have to be the syntax for it. When the server gets a new connection, here's what we do with that connection. Just move this in. Here's what we do with that connection. And I want you to see that if I was to move the code that we wrote earlier, just move all this stuff up. Move this up. The code that we came up with, which is this bit here, right? The code that we came up with could conceivably be wrapped up by somebody else, right, in a function called server on. Right? And maybe instead of just being for on connection, maybe they have an on new data or on closing connection, right? Instead of having to write a whole bunch of different if statements like this, like maybe we'll be able to use syntax like this. Yeah. So on is a function that our server is going to have. And it's specifically a function that we're going to use to register event handlers, right? Meaning, there's often something interesting that happens in the program's lifecycle. For example, there might be a new connection, or somebody might send in some data. Those are interesting things that happen. And we can register handlers to run anytime one of those interesting things happens. The syntax that the people who made this module decided to land on is to say the server on meaning anytime there is a, right? So anytime there is a connection, this is what you should do with that connection. Yes? 100%. So connection is just the name of one of those many events, right? We're going to see that there's a couple different events. Just going to make sure that I got the syntax right. Yeah. So anytime there's a connection, right, here's what you do with that connection. At the moment, all I want to do is console.log someone connected. Right? At the moment, that's all I want to do. I'm going to go ahead and I'm going to comment out our the code that we came up with. This one here. I'm actually going to bring it into our notes because I think this is really valuable for us to see later. Right? So anytime there's a connection, I want to console log someone connected. Do we feel a bit clear about why this needs to be written with this callback style as opposed to an if statement? Right? Mm-hmm.
So is the server.on connection, that's another HTTP function that's running outside of the actual program?
It's just, yeah, it's running on its own. And what it's done is it's essentially made something like this. Right? It's essentially somewhere set a set interval or whatever, right? That we don't even care about, right? What we're dealing with here is an idea called abstraction. And there's probably some very complicated code happening in there. Right? It's going to be something similar to what we wrote, but even more complicated and efficient and whatever. But it's been moved far away from us. And the developers of the net module have told us, if you want to just see if somebody's connected, all you need to do is go server on connection. Right? You're going to find that that's a running theme as a web developer, is packaging up stuff in a nice manner so you can tell other people, hey, I have all this great work that I've done. You can use it in these 4 ways. Right? These just nice, simple ways. Right? Obviously, the first time you see this code, it's freaky. Right? But over time, you're going to find the beauty in wrapping something up like this and just exposing a nice little abstraction. And what I'm going to find now is when I've said every time there's a connection, oh, yep.
Just for clarity, So the server on, that's a method acting on the object server, and it's got default parameters that specify. It doesn't matter for us what those default parameters are. They potentially could be modified by us.
Well, you know what? Let's see. Here, my program is now 3 lines of code. Right? My program is 3 lines of code. It says, bring in the net module, create a server, and then console log what server.on is. Right? I'm not even listening anymore. I commented out the listening part. I'm going to find that when I run my program, this is what server.on is. It's a function that accepts something. If I want to find out exactly how to use this thing, what I'm going to do is I'm going to go create server and then on net node. I toss in just a bunch of things, and eventually I'm going to find stuff like, oh, here's this one, and here's the node modules, node documentation. It's got documentation in here about what a server should be able to do. And this stuff is super terse at the beginning. It's going to take you a while to get good at reading it. But there's a .on method. Then I'm just going to have to go through and find out what the thing that .on can be used for. Server dot. You know, it'd be funny. It would be cool if they'd. Oh, there we go. There's server. So there's all these different events. And basically the thing is, to on, we can ask it to wait for a connection, to wait for an error, or to wait for listening. Right? And each one of these particular events, when they happen, they're going to trigger, as we'll see in a second, they'll trigger whatever the callback is. We haven't even looked necessarily at what this thing is going to be yet. Right? We'll see that soon. Right? All I want us to know right now, though, is that our server is listening, and anytime there's a connection, it'll print out somebody connected. Yes? No. An event is synonymous with, or an event means something interesting happened. Right? Event is a really general term. So an event might be somebody asked you a question. Right? An event might be like you put your hand up. Right? Like that's the.
Something has changed.
It could be, yes, something has changed, right? An event might be somebody pressed a key, like a key on the keyboard. An event might be in the future, I got a notification, right? Or a new user joined. Event is a very generic term.
But it's like an object, not a function.
Yeah, an event is like it's a thing. Yeah, it's a thing that represents something interesting has happened.
Yeah.
Right? So for example, if somebody walks through the door, that's a creation of an event for me, right? I have this event in my head of a person walking through the door, right? Or if you put up your hand, like that's an event in my head. It's a thing that exists saying James put up his hand, right? And then I can decide as a human whether I want to deal with that by saying yes, like what's the question, right? Or I could decide to ignore an event. So if somebody walks through the door, I'm not going to stop my lecture and go, somebody's through the door, right? Like I can decide to just drop that and just move on, right? So in the bless you, in the syntactical sense, you mean there's like a piece of code that. There's going to be a couple different ways to deal with it. For us right now, what we're saying is, in the case of a connection, here is what you do with that connection. Right? And we'll see what this thing is in a second. What I want to do right now is actually start this program. I forgot to get rid of the console log statement. So I want to actually start this program, which is back to what it was before. And I'm going to go here. I'm going to do something like, let me just get this in there so we can see it. I want you to keep your eyes on. I want you to keep your eyes on what's going on with the server over here. But over in my browser, I'm going to go to localhost 9999. And when I go enter, somebody connected. Right? if I was to refresh this and just try again to localhost, the reason I have to refresh is because my browser just hangs. So somebody connected. I make a new browser window, localhost 9999, and oh, well, that's weird. Oh, you know what? It's because both of them are hanging. I'll just have to continue closing and reopening them. Closed. Someone connected, right? So every time I try to make a new connection, I get a someone connected situation here. Yes? Yeah. That I have no idea. Like that was a off the cuff
the way
demo.
I would look at it is
Yeah.
like it's like a direct line.
Yeah.
So like the tab is picking up a phone and it's a direct line to the server.
Yeah.
That tab and that phone is a connection. You're gonna pick up another tab,
Nah.
maybe a new phone, but there's already a line with the other tab.
There we're getting into the specifics of how Chrome is programmed. We're gonna ignore that right now. All we're gonna pay attention to for the moment is just the fact that, like, let's say you had your computers connected as well. When you know, we could do it right now. If you go to the IP address, like you're in Slack right now. So if we were to go to the IP address of, and you're June 24th, like this in your browser, right? If you pasted that in, then in mine, I would start seeing someone connected, someone connected, someone connected. Right? Does anyone want to try that real quick? Right, so over here, it may or may not work.
But how could it work because you can only listen to?
There you go. So someone connected.
It does work.
Yeah. Yeah. So I've given you my IP address. So you're connecting to Nima, and then specifically you're saying, I want to talk to Nima on port 9999. Right? So it goes here. My program is running on 9999. Right? So 9999. Right? And then you're not saying anything to me. You're just knocking on the door. Right? And then my machine, anytime somebody connects, it just prints out like somebody connected. Somebody knocked on the door. Right? What we're going to do in the second half of the lecture is we're going to set up sort of like a chat app where you're all going to be able to write, send information, and then I'll be able to display it on my screen, the information that you're actually sending. Right? Question?
So is it like a token is given to someone and then it's taken back? Like I don't understand how you can have multiple people going through the same port at the same
So
time.
my machine is able to have one program on this end be the listener, but I can have as many people as I want knock on here. Your connection is just like one quick connection, right? Like it just connects, but like my node server is able to handle many connections at once. Right? Yeah, it's like people showing up at a party, right? Like it's not like one person at a time. You can have many people come in. Node is able to handle many connections, right? So that's how like you can have many people connected to the same website at once, right? I mean, there's going to be a limit, right? Because everything has a limit, right? But for practical purposes, right now there isn't really any, right? Yeah, it'll be like the limit will be your machine, like how much can it handle at once. So if we were talking about like, you know, Facebook, like they'll have lots of machines running servers, and each one will be able to handle like millions of connections or whatever, right?
So like you give me this port to us right now. If I want to like hack you, I can just write a script and just send connect to you like million times.
Sure. And it might crash. It might just crash my program, right?
Oh, okay.
Like Node might be able to handle a certain number of connections on my machine, right? And maybe if there's just too many, it'll freak out and crash, right? And that's really about it. Yeah. Yeah. Exactly. So at the moment, like the only thing you can do is just connect to me because I haven't given you any other access to my machine. Like you're just able to connect, right? I'm not even letting you run anything on me, right? So it is 11:05, right? What we understand for servers so far is it's just a program that listens somewhere, right? And what you've actually done right now is you've behaved as the client, right? You've tried to connect to me. You've tried to use my machine. Right? Code-wise, all I want us to understand at the moment is the fact that I had to get my server to start listening, and the way that I had to write the code had to be in this asynchronous fashion because I need the server to continue listening, right? Not just do it once. Right? Continue listening for the connection event. Okay. Are we good to take like a 10-minute break? You look like you have a question. Yeah. Mm-hmm.
Like when you refresh the tab, is that essentially closing the connection and then creating a new connection?
Yeah, it's like a dead connection. Yeah. My server's not handling it right now, so maybe on the server there's like an open connection that it just hasn't dealt with. I actually don't know. What we're going to be dealing with in a second is our connections are gonna we're going to send messages and we're going to receive messages, right? So let's take a 10-minute break, and we're going to dive into a bit of a bigger demo. When we come back, I do want you all to have like your computers ready to code a little bit, because I'm going to have you code the client side of the thing on your machine. Good stuff? Cool. All right, I will see you all at, let's do 11:16. Right. We're missing like 1 or 2 people. So I'm going to slowly get back into it. The first half of this lecture was very much about the theoretical aspects of what we're doing. Right? Just to recap a little bit, the things that really matter are the fact that we need machines to communicate with each other. Machines can communicate with each other through a wire. And the wire is kind of, it's just the Wild West. People can communicate through it by screaming. So in order to clarify things a little bit and have a bit of structure, we come up with some rules. Some of our very basic rules might be that you're only able to take a little bit of time to talk, and then you have to move over. Like that might be a very basic rule. And this establishes a structured way to have some communication happen, but we can still prescribe more structure to it. And what we're dealing with at the moment is TCP. TCP has very little structure. The only real structure that's worth kind of mentioning is the fact that when you try to send a message using the TCP protocol, right, using TCP, if you have a really long message, TCP will break it down into small little messages for you. Right? So it'll send messages as packets. Right? But even if the message gets broken down on the other side, your machine is going to handle reassembling those packets. So between 2 machines, if they're talking in TCP, it feels as if they're just sending lots of text. Right? That's the only real thing that's worth kind of knowing about TCP, is you can send text back and forth. TCP is a kind of protocol that we'll call a duplex protocol. Right? Duplex meaning that both sides of the wire can talk to each other. Right? This side here is able to send information to the other side anytime it wants, and this other side as well. Right? It's a protocol where nobody needs permission to send stuff to the other person, as long as you've established that connection in the first place. Now, what I want to do is code up a TCP client. Right? We're going to code the program that's going to connect to this one that's going to be triggering the someone connected. Because I want us to be able to deal with the server not through the browser, but rather through our terminal. So I want us to be able to talk to the browser through the terminal. To give you a slight preview of what we're going to talk about at the end of the lecture is we're going to talk about what happens when we need really structured communication. Right? We need really structured communication, then we'll come up with a better protocol on top of TCP. So at the moment, this is all the code that I have. Bring in the net module, create a server, tell it that if somebody connects, it should console log someone connected. Okay? Listening, like I'm just console logging, and then I tell it to listen on a port. If I wanted to, I could even print out what the connection thing is in this callback. And I'd see that it's some freaky thing. So I go localhost 9999. It's some big old freaky thing. It's a big object, and it tells me, hey, someone connected. And then there's all kinds of information in here about where that connection's coming from, whether I can talk back to them, all sorts of information like that. It's nested deeply within here. I don't care about that right now. In fact, as far as this thing goes, I'm just going to say someone connected. What I am going to do is I'm going to make a new file, and this one's going to be called client.js. Right? So I'm going to code a little bit, and then I'm going to give you a break to code up what we've written, right? So that you're able to connect as well. The first thing that I'm going to need to do for my client is actually so don't start coding yet. Heads up. In fact, if you'd like, you can enter the folded computer just because I'm going to have to write a little bit of code that I want you to pay attention to. I'm going to start by bringing in the net module again. I'm going to bring in the net module. And then what I'm going to do is I'm going to tell my client program, my client script, to use the net module, and instead of creating a server, I want it to create a connection, right? I want to create a connection, and I want to create that connection at a particular host. This host might be like a URL or something. In my case, it's going to be my IP address, which is 192.168.88.52. That's my computer. And I'm running this server, like the server that I'd made before is running on 9999. I want us to see the fact that there are 2 files right now. I'm going to need 2 terminal windows to run both of these files. Right? This file here is for the server. This file here is for the client. The client's going to connect to the server. This is all the code that I'm going to use right now. Right? Server, client, and I want you to note that in my terminal, I'm going to need 2 windows. In one of them, I'm going to start the server. So like before, it says it's listening on 9999. And in the other one, what I'm doing is I'm starting the client. And my client makes a connection. It's a little slow because, my client makes a connection, and on the other side, I get someone connected. Right? If I stop it, I make a connection again, I get someone connected. So I have this program here technically talking to this other program. It opens up this connection. If I wanted to, I could start sending information. Right? Net create connection opens up that window. Now, just having a connection on its own, not very valuable. I want to have a connection and actually send information through it. I want my client to be able to talk to the server. I want my server to be able to talk to the client. I want us to maybe start by, if you make a file on your computer in whatever folder, it doesn't really matter, called client.js, and you can go ahead and write this code here. Okay. So maybe partner up. You know, not everyone needs to write it, but I'd like a couple people at least to have this written out. And then give me a thumbs up when you finished it. You got me. No.
That smugness was the smugness that he's throwing up.
It was, yeah. Can't believe this guy. Hey, I really just want you to write this first bit so that you get, the satisfaction of having made the connection yourselves. I know I'll bring it up in a sec again, but then from now on, I will actually paste in Slack what the code is. Yeah. Yep, because that's me. Yeah.
We're in.
Yeah, we're in. And when you run your program with Node client.js, right, it should just hang. It's just a number. Yeah, this one needs to be a string because there's dots in it. It might be that if you make this a string, it will work as well, but I haven't tried that. Cool. So let's see. Anybody connected? Whoa, someone connected. Right. Right. All right. From now on, I will just paste it into Slack. And I know you told me to just go back, but I pasted it in. So we want to. So it's in Slack now, and I'll be pasting the rest of it in there as we go forward. What we're going to do is I want to start first by having my server send something back to the client as soon as somebody connects. Right? So inside of my server, I should be able to write some code in here in my server code to say, when somebody has connected, send them a message, right? Where would that live, do you think? Yeah. Inside the callback function, right? So inside of this one here, right? This says when somebody connects, here is what you do with that connection. I might want to, in here, somehow say, send them this thing, right? What would that syntax look like, do you think? Yeah, something like maybe client.send or something like that. In my case here, I've called it a connection, right? So I'd have to go something like connection. And what we'll have access to is write, right? We'll be able to write to a connection. So when there's two people connected via TCP, both of them are allowed to write to the other. So this person here, maybe this is the server, and this is the client. If the client connects to the server is able to write back to the client, and the client is able to write to the server. We'll just have to write code that actually does that. So in here, again, I'm on the server, so you don't need to write any of this. But on the server, I'd like to say something like, welcome. Anything is possible at zombo.com. Has anyone seen Zombo before? Wait, actually? Oh, yeah, okay. Quick sidebar. Zombo.com. This is, if somebody did this as their final project, I would be so thrilled. Yeah. Wait for the music to kick in.
This is ZomboCom. Welcome. This is ZomboCom. Welcome to ZomboCom. You can do anything at ZomboCom.
Yeah.
Anything at all. The only limit is yourself.
So it's a great website.
Is that what the functionality of the site is?
Of our site? Oh, that site?
Yeah.
Oh, that's the whole thing. Yeah, that's.
Oh, okay.
It just keeps going. Yeah. The only limit is yourself. Yeah. Yeah. So I would, if somebody wants to build something similar as your final project, or after boot camp, I can give you funding.
2 gold stars.
Yeah, 2 gold stars. I do have a stamp that I stamp people with anytime they do something neat. So point is, what we're going to do here is I would like to write back to the thing. So anything is possible at Nimacom. Right? No, Nimbocom. I'd like to be able to write that stuff. Now, I'm just going to check some syntax real quick just to make sure that I wrote that right. And I did. Cool. One important thing that I didn't write yet is that we need to set encoding. Set encoding is just going to mean that my server understands how it's supposed to be talking to my client in terms of what characters, what like key characters does my client accept. Right? So like the letter A and B and C. This line here is just going to say, use your standard character set. Right? UTF-8. Now, when I make my connection now, I should receive back anything is possible at Nimbocom. Right? I'm going to keep my server running and my client, and I'm going to start my client. So here's my server, and here's my client. It goes, and nothing happened. Now, nothing happened because I did not explicitly on the client say that I wanted to print something out. I need to, on the client side, say, if I receive a message, then print it. Right? I need to be able to say something like that. So my client code here, my client might be able to say something like, anytime there is a connection, client.on connection. Oh, and as part of this, I'll need to have to say const client to actually save my client as a variable. Anytime there's a connection, maybe here is what I do with the connection, or with the message that comes back. So I might go console.log stuff, I guess. Now, I'm gonna be honest, I actually haven't run this code before. Just gonna see what happens. So the server is responsible for itself, and the client is responsible for itself. So my server might send information back. The client does receive it, but it is up to the client to decide whether or not it should print it to the screen. Right? It's up to the client to decide what it should do with the data that it receives.
So it's the conduit, and the server is essentially like the warehouse.
Yeah, you could definitely think about it that way. Yeah.
Couldn't you theoretically, instead of passing the object, or just instead of passing the data of like what is being put out, couldn't you pass over like an object with the function of doing this?
You could pass over all kinds of stuff. The limit though is we can only send text, right? Through the wire, you can only really send text. You could send text that represents code if you want, but then there we're gonna have a whole new standard, right? The most simple thing that we can send back and forth are just zeros and ones that represent text, and we just have to agree that they're gonna be text. Right? If we do meet up beforehand, though, then we can agree that we're going to send back other kinds of data, right? Like an image or something. But in this case here, it's just text. That's actually part of what this is saying, is that the information that I'm sending is going to be text.
You could set up parameters that allow like more extensive uses of communication.
Exactly, in theory. And that's something that you will be working with. Yep. Yeah, that's a great question. That is where JSON comes in, and you'll be playing around with that a lot once you get into HTTP. Yeah. Was that a question? Mm-hmm. Not necessarily. To be honest, like we could play around with toggling this on and off later and seeing what happens. There might be, depending on who made the thing, right? For right now, I just want us to accept that I have to write this line, right? What I do encourage you to do, though, is afterwards you can take the demo and toggle this line on and off and see what happens, right? Right now, though, on my client side, I do need to say anytime I receive something or something like that. I've written it as an event handler that when I make a connection, here is what happens. I'm not sure if this line of code will work. Right? So I ran it, nothing really happened. Turns out apparently this does. Yeah, I know. I was gonna. Yeah, it's gonna be data. Great job, Renee. Yeah, it will be anytime I receive data back from the server, right? So anytime that my client receives data, I might receive a bunch of stuff, and I could decide to console log what that stuff is, right? So if I go ahead and I try to restart my client now, I end up getting back a bunch of stuff, right? And this is kind of a bit of an answer to your question. What I got back was a buffer of 56, 65, blah, 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 blah. Not exactly, welcome, anything is possible. It's a little bit different. Because my client now needs to know what kind of information am I receiving. So over here, my server is telling itself that I'm going to be sending stuff in that thing. But over on the client, I might also need to do that. I'm realizing right now that I had toggled that off. So I brought this back in, and I'm just restarting the server. So the server's running. But yeah, anytime I run my client, I get back this buffer. And you can tell it's the same information every time. See, it's the same thing. So it probably represents that hello, yada, yada, yada. I'm just going to need to be able to decode it properly. So in just one sec. So what I'll need to do is over on my client side, I'll also need to say something to the tune of my client is going to receive. So my client is going to receive in UTF-8. So that my client understands how to look at the data that it gets. Right? And now, when I restart my client, the data that I get back is actually read properly as opposed to just being that buffer. Right? I want to stress, this is not something that's very important right now. Right? The only thing that's important is the fact that these two are communicating. Right? If you really want to understand this line of code, all this means is server is telling itself, I'm going to be talking in English, and the client tells itself, I'm going to be understanding in English. Right? That's all that's happening. Right? There's other kinds of encodings that I could pick, but I'm picking UTF-8 right now. So I have my server sending some information. I have my client registering the fact that anytime somebody sends data, it will get printed back. Now, what I want you to do is take this code, which I will paste into Slack for you. And if you do have your laptop open, you can update your script to look like that. And I just want you to see that you will get back stuff with the hello and the welcome. Mm-hmm. Yeah, it's a type of object in this case. It's a type of object that's just going to hold data. Yeah, buffer is a generic term for like a bucket that holds a bunch of data. So yeah. Mm-hmm. Mm-hmm. Exactly. That's a perfect way to put it. Yeah, just temporarily created, and it's just going to be used to hold something. In our case, it holds some data that then we might read or something like that. No, not in our case right now. Yeah. Mm-hmm. So I think the Russian alphabet is inside of UTF-8 anyways, but there might be different ways of representing the Russian alphabet, right? So ASCII is an encoding, for example, or there's going to be other ones. UTF-8 kind of covers everything. It's a really, really big encoding. Mm-hmm.
It's basically just a set dictionary for computers
Yep.
to interact, not specifically with the language, but just like how they're going to talk with each other.
Yeah, with what text is. So UTF-8 is like a mapping that says, okay, 0001 is going to be an A. 0010 is going to be a B. 0100 is going to be a C, or something like that, right? It's just a mapping. Because the server is going to send back 011100 like that, and my client just needs to be able to interpret that, right? So UTF-8 is just one mapping of zeros and ones to letters and symbols, right? Because I might work at a company that was established before UTF-8, right? Like UTF-8 happened in like some year, and I might be using some other encoding. Yeah, like I might be using ASCII. Maybe I'm working somewhere where I've created my own encoding for like efficiency reasons. Maybe at my company they say, hey, UTF-8 is really bloated. Let's make our own because we don't need Cyrillic and we don't need like traditional Chinese characters and stuff. We just need like an A, a B, and a C. So I might make my own encoding that's just more compact. Right? In our case, though, in your case for almost forever, you're going to be using UTF-8. Right? Mm-hmm. Yeah, because you can't leave this once it's up. The thing that you can do is Control-C to leave. Right? So what we're going to build in the next couple minutes is we're going to build an app that's going to let us send data from the client and receive data, right? Because right now your server or my server sends you stuff. Was anybody able to actually receive the welcome, anything as possible? Cool. An app, right? I guess an app is like a theoretical, like it's an idea. An app is a frame of mind. It's where you say, I've created a bunch of features and they work in a particular way. What I'm defining as an app right now is I'm making one script that does my server, and I'll call that an app or a program. And then another one that's my client, and I'll call that an app or a program. App just means application. It's just one kind of encased thing. Right? So in super broad.
What's different between a large function and
the fact that you run it and you use it, right? For us right now, it's just a thing that we use, right? So in my case here, I'm using the server, so I'll just call my server an application at the moment, right? Somebody just connected again, cool. As you go further, this is going to get a little bit more solid. So we might talk about what a web app is, right? But just give that a little bit more time. For now, just accept it. I made a mistake, and instead of calling it a script, I called it an app. Like, just because I didn't want to reveal that kind of vocab yet. Yes, and then yes.
More so just like maybe trying to answer his question. Would it be like a collection of functions that work together to serve like a purpose?
Yeah.
You can run a function, but you can't use it, or you could, but very rarely use it in isolation. Whereas an app would be several functions put together.
Yeah.
And similar to a program, but more specific.
For us right now, I'll say that a program and an app are going to be the same thing, right? It's just I've decided to write some code to do something, and then I run that code, right? That thing is an app or it's a program, right? It's some software. That's what it's going to be. You had a question?
Yeah. Okay. So back to the server again. So every time you connect to you, so you will receive the server will receive some information from us, right? Like by computer, so our IP address will store at that connection.
Yeah.
So you're able to every time someone connects to you, you can print out. Someone connected IP address.
Yeah, I could dig into it and find the IP address and all that. Among the things that, what's that?
What else? When you connected.
Yeah, like when you connected, maybe what type of machine you're on and all that. Yeah. I would think so as well. I've never dug deep into into the thing. I totally invite you to dive into this object though and see what's in there. For right now though, I'm gonna write a couple more lines of code. The first thing that I want to do is I'm going to make an array, and I'm going to call this one everyone. Right? This is my array of everyone, meaning it starts off as an empty array, but then anytime somebody connects, maybe I want to take everyone and push to it that person who just connected to it. So in theory, what should happen is that as everybody connects, this array here is going to fill up with people. And the reason that I might want to do that is because maybe I want to send a message to everyone all at the same time. Okay? For example, I might make a function that I'm just going to call something like broadcast. And what this function is going to do is it's going to take some text maybe, right? Or like a message. And what I'm going to do with it is I'm going to say loop through everyone. So for person, we'll go for let person of everyone. I just want to check, have you seen this kind of for loop before? Cool. So for every person in the list, I'm going to write to them someone connected, right? Or I might write to them whatever message I want to pass in with a broadcast function. So maybe what I want to do is whenever somebody connects, I don't just want to send this message, and I don't want to just console log on my own terminal, but I want to broadcast to everyone someone just connected. Right? So now everybody receives a message that says someone has connected, and I had to write that code to loop through everybody. Right? So this was a multi-step thing. I'm saying somebody connects, I put them in a list, and then I made myself a function to go through that list and message every direct person. Does that make sense as an idea? Cool. Again, we don't necessarily need to understand the full code, but as an idea, I just want you to know that I'm holding onto this connection somewhere. If I restart my server and you try to connect now, what you're going to get is someone just connected. right? And you see on mine, on my client, every time somebody connects, that message pops up. At some point, for some reason, my thing died. Oh yeah, you know what we've probably run into is like a maximum number of people that can be connected or something. Yeah. Oh no, the socket has been ended. Who knows? Yeah, so maybe I hit a limit or something, or maybe I just wrote bad code. But what we do know is that for a little while it was running. Right? We could try it again. Oh, I bet somebody's trying to DDoS it or whatever. Did you write a script? You wrote a script. Yeah. Yeah. So this idea here, now I'm broadcasting to everybody who connects. Right. So, yeah. So I've taken my server down. We're going to slowly wrap up the chat thing. I'm going to have to write a bunch of code, and I'll paste it into Slack so you can bring it over. The code that I'm writing has less to do with networking and more to do with accepting stuff from the keyboard. Right? It's similar to stuff that you did yesterday. Question? Mm-hmm. 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 I think that's definitely what we should be focusing on. If you want to pick up on the code, that's cool. For example, this broadcast function, not a thing you need, right? The broadcast function is just something I'm showing you I've built up, right, to handle. If you wanted to go through it and try to like really learn it, then that's cool. But the main thing to focus on right now is the idea that TCP just lets people shout at each other, right? There's going to be a server who handles all these connections, right? And then we're able to talk back and forth between each other. Yeah. That's the main thing. Yeah. Mhm. For sure. And so today's activities are going to be very much of like everyone kind of working together through stuff. So networking is a big concept, right? It can feel scary, but you're going to get a ton of time to work through this and get really familiar with it. And like you asked at the beginning of the day, as a web developer, you're mostly going to be working higher up, right? So the code that I'm writing now, for example, you won't actually be writing this kind of code in the future, right? This is like learning code, right? In the same way that when I think what was your name again? Brian? Brian, like you suggested doing the set interval and all that to see if somebody had connected, and then I said, oh, well, with the net module, we can just go server dot on, like somebody abstracted that for us. That pattern continues forever. Like somebody will have taken pretty much everything that we're going to write today. Somebody will have taken that and packaged it up so that it's like you don't need to write that anymore. Not necessarily, right? More like, yeah. This what we'll see is a framework in the future. That's an interesting idea that you're getting to, though. So heads up, we will go over by like 5 minutes, so just be all right with that. Now, what I want to show you on the client side, right? I'm going to set some requirements for what my client's going to do. On my client side, I just want to be able to write, and then every time I press enter, it should send a message. Right? That's the first thing that I want to do. And then the other thing that I want to do is I want to be able to quit my program. Right? Now, on the client, I'm going to need to start off by bringing in standard input. I don't like writing process.stdin all the time. So instead, I save it as a variable called standard in. Right? So I have this thing here. The next thing that I'm going to have to do is I'm going to have to say that standard in is also going to be speaking in that UTF-8. Right? So my keys are going to be UTF-8. The message that goes through the wire, that's going to be UTF-8. All that stuff, all UTF-8. Right? So again, really want to stress that what I'm doing right now is just specific to my demo, right, to get the message working. And here's the line, standard in resume. John, what does standard in resume do? Yeah. We may or may not need this line. So, yeah. Yeah, so yeah. We'll just not have that line. Easy. But what I do really want to care about is a message or a handler in here that says something to the tune of, with standard in, I'm just going to get rid of all of these comments real quick. And this is identical to what you did yesterday, correct? Standard in dot on data. Did you do this kind of stuff? Is that a yes or no? I just can't remember if you've done this activity yet. You have? Yeah. So you have seen this kind of code before. There we go. Okay, that's all I need. Standard in, anytime there's some data, I can do stuff with data. This is saying to my program, listen for people to write on the keyboard. Right? So I might console log whatever that data is. Right? And if I was to look at my client right now, if I was to look at my client and start it, anytime somebody types something, like I would like to be able to print out data. I would like to be able to print out what that stuff is. I think I just got the syntax wrong here, for, which I'm going to fix in a sec. You had a question though? I mean, oh, data comes in when you press enter. Like, that's what I'm going to be sending from the client to the server. Yeah. That's the problem. Yeah, good call. I was in the wrong tab. There you go. So what I would like to be able to do is type and then press enter. And every time I press enter, I want to do something with that data. Thanks for catching that. So we're going to write stuff like, hey, what up? Right? And that message, the hey, what up, is what I want to send to the server. So I'm able to, inside of my client, say, anytime that there's data, I could write to the server. I could send that message to the server. So for example, I have on data, standard in. I'm just looking for where I wrote that client.write. So inside of this thing, I would go client.write, and then I'd have to write what particular data I want to send, which is just going to be the data itself. And so anytime that somebody writes something, it's going to be sent over to the server. Mm-hmm. 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 So this thing here is like the connection to the server. Right? This one says anytime the server sends me stuff. And this one here says anytime I write some stuff and press enter, it'll send it to the server. Right? Exactly, right? Because in TCP, the server can send stuff and the client can send stuff to each other. Right? That's how TCP is going to work. So what we'll notice, though, is when I run this, error event, let me just, my server isn't running. Yeah. When I run this now, I can write stuff, and then I'll be able to quit with Control-C. I'm not actually seeing any messages being sent anywhere. I need my server now to listen for data. I look at my server, and my server just says anytime there's a connection. But I can also say anytime that connection sends me data, then I can do something with that data. For example, I might broadcast message, like new message, and broadcast out that message. Right? I should now be able to, both on the client, send messages and receive messages from people. Right? My client didn't change too much. I'm just going to save and see what happens now. So we'll have to restart the server. We'll have to restart the client. And now when I say something like hello, I get back, all right, new message, and then I didn't actually get the message back. So fun, I get to play around with that now. At least we're all getting new message though. So it's kind of like a useless chat app. Right? Yeah. Yeah, that's I tried to use this like a console log. It should be plus data. That's what it is. Like the comma wasn't. I just written like I'd made a syntax error. Now I broadcast back new message plus the message itself. Let me just restart the server. And we'll try this out now. And I go, hey, what up? Sweet, new message. Hey, what up? And then we can do things like, wow, thanks, whoever did that. Easy. You know, we can do all kinds of stuff like that. Sup, Andy? Yo. So someone's just pasting a hey, yo, 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 yo. Woo. Right? Brrrah. Yeah. Right. So we get to chat back and forth. If I wanted to, I could make my client print out less of this new message stuff. Right? I could even do things like give every particular client a number. Like, say if I'm going to turn off my server for a second, my client, and I'll do something like let user equals, like, I don't know, math.random between 0 and 1. Sure, just math random. New message from user. from user. So this should technically now have everybody get some weird random number every time, but it's like consistent for everyone. So new message from user, and then that's my username. So my username is the same every time, but if one of you was to send a message now, you'd have a different random username. And does somebody just want to test that real quick? There you go. So now we have all sorts of different users sending stuff. Hey, Mr. B. Yeah, that's Dr. B to you. There you go. Oh, no. You know, it might be the apostrophe or the dot. Who knows? No, the dot's fine. I have no idea. So, yeah, shut down. Oh, my server itself crashed, which is funny. So, point of it being, though, we have some rudimentary chat application. Now, it is 12:01, and I said that what I wanted to end the lecture with was a brief, very, very brief conversation about what HTTP is. Right? You're going to be exploring HTTP in depth over the course of like future lectures, but I want you to notice that really all we've been able to deal with is like I just send text back and forth. And as we work on bigger applications, on bigger programs, we might want to have some more refined method for communicating. And we might want to have a little bit more structure in the way that communication happens. Specifically, the paradigm that we're going to be thinking in moving forward is there will be a server who is responsible just for listening and replying. And there will be a client who is responsible just for asking and receiving. Right? meaning that a server will not be able to send stuff to a client unless a client asks first. And HTTP is just a particular way to use TCP. If we wrote our program such that our client and our server went serverous Snape. So such that our client makes a request to the server, serverous Snape processes the request and then sends a response, and the client receives the response. That is HTTP. Okay? HTTP is just us using TCP in that method, where we write the code so that this is how we agree the communication is going to happen. Right? There's a little bit of fluff to HTTP, specifically such that a request looks like it has a kind of request. For example, am I asking to get some stuff? Do I want to create a new thing? Right? For example, creating a new user or a new message. Right? Our request that we send is going to have to be written so that it says what kind of request it is. AKA, is it a get, post, put, or delete request? And we'll also have to say, optionally, what is the data that I want to send? For example, if I want to create a new post, or I want to create a new user or a new video, I need to actually pass that data. Right? So every one of our requests in HTTP will have the words get, post, put, delete. You will learn what those mean. But for right now, they're just going to be indicators of what kind of thing I want to do. They're going to have optionally some body, some data, and then also extra information for like identification. Do you remember early on I said that maybe when the voices are screaming in your head, you'll tell them, hey, how about every time you scream, not only do you only get 5 seconds to scream, you also have to tell me who you are. Right? HTTP says that. It's a protocol, it's an agreement between people that the messages we send are going to have extra information for identification. Right? The server can do stuff with it, and then at the end of the day, the server sends a response, and the response is going to have a status code. Right? A status code meaning, did it work? The thing that you asked me to do, was I able to do it? Right? Did you have permission? Okay? Maybe you didn't have permission. Maybe something broke. Since it's such a common thing for us to need to be able to explain to the client from the server, did something go wrong? Or did something go right? We come up with status codes, like 200. Have you seen 404 before? 404 is a status code. It says, I did not find what you were looking for. Right? 302. 302 says, I don't have the thing you're looking for, but this other person does. Right? 500. I don't know what the heck went wrong. That's fine. Something went wrong, and I don't know what it was. That's what 500 is going to be. Right? Again, I'm pointing these things out right now, not because there's something you're going to necessarily use too much at the beginning of the day. You're going to get introduced to it at the end of the day. Right? And you're going to spend a long time getting comfortable with this. Right? I just want you to know it exists. The response will also have some data that you asked for. Okay. Now, there isn't enough time left in the lecture for me to show you creating an HTTP client necessarily. I will be using one real quick. But what I do want you to keep in mind is that HTTP is a layer on top of TCP. It just says, this is how we should use TCP. And in fact, if you really wanted to, I don't recommend doing it, you can go look up HTTP RFC. An RFC is just a kind of document. It's like an email, like a very official email. You can go look at the original documentation that says how HTTP 1.1 should be used. And you could dig through it. Made by the Internet Society. Right? Whoa. And you can go through it and it'll tell you all about how HTTP is supposed to work. It's a huge thing. I've never read all of it. It doesn't matter. Right? But they will tell you, like, the point of HTTP is blah, 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 blah. You can dig through that. If you want to see an example of HTTP being used in practice, that's me using HTTP. My browser, every time I make a request through here, is going to make that request in the HTTP format, right? Using the HTTP protocol over TCP, where it sends a request and it expects something back, right? What did I expect back? What's that? Adele, apparently. Right? I got back a page, right? And that's something you're going to explore in the future. If I go to dogs.com, ooh, I don't know if that's we'll see. We'll find out. What? PetSmart owns dogs.com. All right. Right? I made a request and I got something back. Yep.
So basically the way that we look at it is like, these are just like, you're constantly layering like dictionaries and expectations, communicating through different, levels of software and hardware. So it's just like,
layer on layer on layer.
HTTP is how you deal with the TCP,
Yeah.
which and it keeps cascading down. So you're constantly manipulating and translating the data.
Absolutely. Right? So it's like a pancake. Eventually, you will find something on top of HTTP, and you'll find something on top of that. Right? There's always going to be just more and more and more added to the top. And then when you make your way down, the very basic place is the wire, and it just turns on and off. Right? That's it. So this is where I want to stop today's lecture. Right? Did you find this useful? Is it helpful? Right? Do you feel like you understand a little bit more about TCP than you did before? Right? I don't want you to be able to write this code immediately right now because your activities are going to take you through that. Right? I will send out notes. It might just take me like 30 minutes or so, but I'll send those out. If you have any questions, just Slack me. Again, it's Nima, or I'm usually sitting there. Have a great rest of the day. Well, thanks, everyone.